Hi everybody, so today we're going to be doing notes on section 9.3, which is solving equations by taking the square root. So this is why I went over the simplifying radicals a couple of days ago in the notes, because that's really going to help us here. So go ahead and pause and write this down. All right, so step one is to isolate the squared term. What does it mean to isolate something? If you said get it by itself or something along those lines, you are correct. So get it by itself. So whatever our squared term is, we want that by itself in the problem. Then we'll go on to step two, which is to take the square root of both sides. And then last but not least is to solve for our variable. So let's go ahead and look at some examples. Part A. Is my squared term by itself? You should have said no. I have this 2 that's multiplied by it and this 98 that's subtracted. So I have a few things in the way that I need to move. So first thing I'm going to do is add the 98 to both sides. Now normally when I do these problems on my own and on your homework solutions, I don't show all of these steps, but I am choosing to show it in the notes so that you know exactly what's happening and why. So adding the 98 to both sides, we end up with 2x squared equals 98. Now my x squared term is almost by itself, but it has a 2 multiplied by it. What undoes multiplication? If you said division, you are correct. So I'm going to divide both sides by 2. And then I will be left with x squared equals 49. Now that my squared term is by itself, I can take the square root of both sides. So that's what I'm going to do now. So I can take the square root of the left side and the square root of the right side. So let's see. I'll write a little note. Take the square root because the squared term is isolated. So we can take the square root of both sides. Now, I'm going to write one extra step for this problem that I'm not going to show on the other examples. The square root of x squared is x equals, now I'm going to rewrite this as the square root of 49, but now I'm going to put a plus or minus out in front. And the reason for that, bring that over here. This plus or minus, that's how we say it out loud in words when we see that term. So when that term is written, we say plus or minus. Always, 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 always put plus or minus when you take the square root of both sides. Oops, sorry, that's cut off a little bit. Now the reason for that is because, you remember from our other notes with simplifying radicals, 7 squared is equal to 49, but negative 7 quantity squared is also equal to 49. So that's why we have to include that plus or minus out in front when we are solving these. Excuse me. Sorry about that. That probably sounded kind of weird. I had something stuck in my throat. All right, so when we take the square root of 49, this is a perfect square, so it works out real nice. And our answer is just x equals plus or minus 7. That's our answer. And we're done. All right, let's look at another example. Part B. Is my squared term isolated? You should have said no. So what do I need to do first to get the n squared by itself? If you said something along the lines of subtract 12 from both sides, or minus 12, or move the 12, anything along those lines is fine. So subtract 12 from both sides. Then we get 3n squared equals 0. What do I do next? You said divide both sides by 3. You are correct. So now we're going to have n squared equals 0. So now that my squared term is isolated, I can go ahead and take the square root of both sides. And remember, when I do that, I add the plus or minus to decide with my answer. So n is going to equal plus or minus 0, but 0 can't be positive or negative, so we just write 0. And we're done. Not too bad, right? I don't think so. Let's look at another example. So what am I going to do first? If you said subtract 25 from both sides, you are correct, because we need to get that squared term by itself. So now I'm going to have w squared equals negative 20. Do you notice anything different about this problem that we didn't have on the others? If you said that it's equal to a negative number, you would be correct. So any number squared, we could square any number humanly possible, 0, positive numbers, or negative numbers. No matter what, when we square stuff, the answer is always positive, which means having this statement saying that a squared term is equal to a negative number is absolutely not possible, which means the answer to this is no solution. This is easily one of the most common mistakes that gets made because people are just so used to going through the procedure and saying, oh, my squared term's by itself, let me just take the square root of both sides. But it's really, really important that you always check and make sure that the number it's equal to is a positive number. So let's write a little note about that. So once it's isolated, that is the key. And by it's, actually, I'll clarify that. The squared term. So once the squared term is isolated, if your square root, or sorry, if your squared term is equal to a negative number, it's no solution. So if it's equal to a negative number, it will be no solution. Once it is by itself, because it is possible to have a problem where, say you have all this stuff on the left and it's equal to a negative number, where once you move stuff over, it becomes positive. So that's really important, once it is isolated. Let's look at another example. So this one has a lot more stuff going on with it. We have stuff multiplied, we have parentheses, we have stuff subtracted, lots of different things going on. So for this problem, my squared term is this whole thing. This is my squared term. So my goal is to get this thing by itself, which means I need to get rid of the 2 that's multiplied out in front and the 50 that is subtracted. So what I'm going to do first is add 50 to both sides. And then I'm going to have 2 times parentheses x minus 4 quantity squared equals 50. So I'm halfway there. Next, I will divide both sides by 2 because 2 is multiplied by this thing in parentheses. And to undo multiplication, we divide. So now we will have x minus 4 quantity squared equals 25. My squared term is now by itself because this whole thing in parentheses is what's squared. So that whole thing is the squared term. So now I can take the square root of both sides. And again, plus or minus. That's also one of the most common mistakes that gets made is forgetting that plus or minus. So I'll put a note here too. This is the squared term. Alrighty, so what we're going to do now, if we take the square root of this squared, which by the way, the reason why we can cancel that out, why taking the square root of that works, is because just like, let's say for example, looking at the square root of 25, we know that that's 5, but what this is actually saying is this is the square root of 5 times 5. We have 2 of them, which means 1 can come out. So it's the same idea when we had the square root of x squared. That's like saying the square root of x times x. There's 2 of them. So the square root is x. And it's going to work exactly the same way here with the x minus 4 all under there. This is like saying x minus 4 times x minus 4. So there's still 2 of them, just like before. It works exactly the same way as all of the other ones. All right, so when we take this square root, we're just going to have x minus 4 equals, what's the square root of 25? You should have said 5, either 5 or plus or minus 5. All right, so now this is where it gets a little bit more difficult. With all the other ones, we just solved it and we had x equals a number. Now my x is not by itself, so I have to go one step further. So what we need to do is say, this is similar to the idea with factoring, is either the x minus 4 equals the positive option, so positive 5, or x minus 4 equals the negative option. Then we have to get the x by itself. So we add 4 to both sides, add 4 to both sides. So our final answer will be x equals 9 or x equals negative 1. Now you can choose to write those in whichever order you prefer. If you had switched these things that I wrote in blue, and then your answer said x equals a negative 1 or x equals 9 and they were switched, oops, hang on, there we go, and they were switched, that's fine, it would still be correct. All right, let's do another one. So this one looks really, really similar. So tell me, what are we going to do first? You said subtract 7 from both sides. You are correct, because our goal is to get that big old squared term by itself. So I'm going to have 3 and then parentheses x minus 2 quantity squared equals 48. Then what do we do next? You said divide both sides by 3. You are correct. Cancel out that 3 that's multiplied out in front. So then I will have x minus 2 quantity squared equals 16. What do I do next? You said take the square root of both sides. You are correct. So square root of the left side, square root of the right side, add the plus or minus. So now we're going to have x minus 2 equals plus or minus 4. Now I want you to go ahead and try this next part on your own. So push pause, and then when you're ready to check, push play. Alrighty, go ahead and check your work. So I wrote it again in blue, showing the two different options, and you should have gotten 6 and negative 2. All right, last example. What am I going to do first? You said divide both sides by 2. You are correct. So this one's nice. We only have to do one thing to get our squared term by itself, get the squared term isolated. So now we will have x minus 6 quantity squared equals 48. What do I do next? You said take the square root of both sides. You are correct. I add that little plus or minus. All right, now this is where it gets a little bit different than what we've seen so far and where it's going to bring in our knowledge from a few days ago. So x minus 6 equals plus or minus the square root of 48, because 48 is not a perfect square. So we can't just take the square root of it. So what I'm going to do now is draw my little tree. So my options for this, I'm going to show you again with the calculator just to give you a little refresher. So 48, I know that 2 goes in, so 2 and 24 is an option for my tree, or 48 divided by 3, so 3 and 16 is an option. 48 divided by 4, 4 and 12 is another option, and then you could keep going. But I already know which one of these on here I would pick. 16 is a perfect square. So if I choose 3 times 16, my tree is done. I don't have to extend any more little branches. You could absolutely choose one of the other options, or you could do 6 times 8 as well. But then you would have to keep continuing drawing your little tree. So I'm going to choose 3 and 16, because then 16 is our perfect square, and 3 is the leftover that's going to stay inside of the radical or underneath the radical symbol. So when I write this out, it's going to be x minus 6 equals plus or minus what comes out of the radical. If you said 4, you are correct, because the square root of 16 is 4. Rad 3. Now a refresher for this as well, if you're still having trouble with the radicals, the square root of 48, we just determined 48 is 3 times 16. So that's like saying the square root of 3 times 16. The square root of 16 is 4. That's why a 4 is what comes out, and then the 3 stays left over underneath. All right, now one last step is we still need to get the x by itself. So this is the part where it's a little bit different than what we've seen so far, because we have a radical over here and not just a whole number. So when I do this, I'm going to do this in regular pen this time. I'm going to have x minus 6 equals positive 4 rad 3, or x minus 6 equals negative 4 rad 3. Now both of these, I have to get the x by itself. So for all of these, or both of them, sorry, I'm going to add 6 to both sides. And we know the 6 cancels out on the left. But this is the part that's new that you probably haven't seen written before. This radical term and the 6 are not like terms. They cannot be smushed together all as one term. It's not like saying 2x plus x. These are not like terms, so they have to stay separate. So this one on the left is going to be written as x equals 6 plus 4 rad 3. And then x equals 6 minus 4 rad 3. And put the or in the middle. So you can either write it like that, or you can write it as x equals 6 plus or minus 4 rad 3. Those mean the exact same thing. Just like how when we write x equals 5, comma, x equals -5, you can write it like that, or you can write it as x equals plus or minus 5. It's the exact same idea. Now, the last thing that I'm going to point out on here is this whole thing is not 10 rad 3. You do not add that 6 and 4 together. They are not like terms. Same idea with this one. This is not 2 rad 3. You do not subtract the 6 and the 4. Do not combine them. That's really, really important. Alrighty, that is the end of our notes. Have a good rest of your day.